Okay, so first of all, as usual, I want to thank InsomniHack, scrt, basically everyone that organized this great event. I'm really excited to be here. This is my first time in Switzerland. You have a great country, specifically here in Lausanne, right? I pronounce it well, I guess. So let's start with this. We have attacking and defending GraphQL, the ultimate guide. My name is Juszkiewicz. So let's start. First of all, you don't know me. So let's start with a quick, who am I? So I'm originally from Mexico. Yeah, I can prove that. Basically because I love chili. I love spicy. If you see me somewhere around just pouring some chili on my soup, don't worry. This, I was born like that. Also, other hobbies that I have as well. Swiss chocolate. Not because I'm here, I'm telling you. I always love the Swiss chocolate, soccer, or football, whatever you call it. Used to get certified. Wasn't sure if I was supposed to say that or not, but, I have all these OSCP, OSCE, CPPT, EMAP, EWPT, PTX, so on. But not anymore. I work as an application security architect in Dario Health, which is, as its name implies, it's a healthcare company based in New York. I do a lot of stuff, like design reviews and making sure the code and processes, everything is as secure as possible. I used to be in my previous jobs, security researcher, but mainly in the web security area. And also, when I have time, I am pursuing my MSc, my master's in cybersecurity from the University of London. And basically, that's all about me for now. So the agenda for today is going to be just a quick overview about what is GraphQL. Maybe some of you are familiar with, maybe not. So we'll just give a quick recap, and we'll start gradually moving on to more topics, more operations, directives, and more less common stuff, actually. We're going to see also some terminology because we need to understand that in order to understand attacks and how to defend ourselves. We will do also a comparison with other APIs, so the RESTful API, which is the most the wide known technology. And we will see also a real exploit scenario, so we can see how things go in real life. But also we will see other attack vectors, other places where we can be hacked or attacked if we are not aware or we not care enough. And lastly, of course, we're going to see some remediations or ways to mitigate those, how we can defend ourselves, how we can make sure that if we adopt or if we adopted already this technology, so we are safe. So let's start with a quick overview. But before that, I would like just to clarify. I don't know, just somebody saw me downstairs and he was like, "Oh, you're a hacker, so you're probably on drugs." I'm like, "No, dude, I just have red eyes. Just went to the doctor, so I'm not on drugs." Okay, so API basics. So you already know what an API is, or if not, it's just it allows you to exchange data or information with different applications. Usually you follow some rules, some header, some token, key, password that you need to share with the service provider, or the service provider actually provides you. Let's say, we want to query the weather information for today, so we set a set of rules, set a few fields that you need to provide in order to get the full weather, or just one piece. But APIs became really crucial in just last years, because they bring a lot of benefits. This is the way of exchanging data between my app and the rest of the applications. Okay? We see them, basically all over. If you know YouTube, if you know, Facebook, basically almost every single application in the world, mostly the public ones, they share some kind of information or API for you to reuse and query their data. If you want to get, let's say, your video and you don't want to go and click on your video link every time you want to get the viewers, or you want to get some other information, you usually do this through an API provided by the service provider. But as well, if you want your service to be used by other users in the world, other services. So you need to provide that also as well. So almost 70% expect to rely even more on APIs on 2023. That's according to stateofapis.com. But that's just a number, okay? It could be, millions of users and millions of applications as well. So we used to have something called the traditional REST API or RESTful APIs, and that used to be the standard. We know we have several methods: HTTP post or put to create or modify data. Delete if you want to remove some item, something on the server. Get if you want just to retrieve data, you want to read data from the server. And we used to have many endpoints. Okay, we will talk about this later. And also the way of interacting with the server, it was by using JSON or XML. XML maybe less common, but if you know Google Cloud or one of these services, so they still use kind of like an XML API where you can actually use XML as part of the, to call the API service. But we used to have many endpoints. Like if you want to query for orders, you want to query for users, history, logs, every service or every component of the application is just another slash something, sometimes a few slashes. That was just basically the RESTful or the old or the traditional method that we know. So the economists, just to reinforce a little bit more about this, they said, I think it's in 2017, I'm not affiliated with them. Okay. So they said that the world's most valuable resource is no longer oil, is data. Okay. And when we talk about data is the API, because this is the way of exchanging the data between you and the application. Okay. So if you want to invest, maybe this is your opportunity. Not sure. Yeah. If REST actually stands for relaxation, RESTful APIs. So let's see a few GraphQL fundamentals now. What is GraphQL? So GraphQL is an open source data query and manipulation technology that is used for APIs. It was mainly created by Facebook or Meta back in, I think it was in 2012, and they released this to the public in 2015. Why they did it, or what's so great about GraphQL? So first of all, is flexible. Okay, you can change pieces in amount of just seconds or minutes. You don't need to change your whole architecture in the front end or in other places. And it's very efficient, okay? Because we will see later how you can just query only, or basically send only one request with many queries instead of sending dozens of queries for that. Also, one of the problems we'll see later by comparing them. So one of the problems with REST APIs is that you get everything. You query for orders, you get all the orders. Okay, you can query for the ID, but you get sometimes all the details, not really necessarily at this moment, but you get everything on the same packet. And with GraphQL, you specify what exactly you want, okay? So in many cases where you need compliance, HIPAA, GDPR, or whatever, and, any other regulation, and you are requested not to, everyone basically, but specifically these companies much more. So they reduce drastically with GraphQL, the disclosure of PII or PHI, personal identifiable information, or PHI, which is the same acronym just for health information, like diagnostics and stuff like that. So when you query the API, you get the exact information. You get the name, because that's what you requested. You get also the phone, if that's what you requested, but you don't get the phone name, address, and also different information that you didn't even ask for. Another advantage here is that it's a strongly typed language. Otherwise, errors will be thrown. That means that as opposed to, you could do it also in RESTful APIs, but you need to have some work done in the back end. What you need to do is just to query specifically for that type of data, whether it's an int, a string. There are also some scalar types or built-in types that are called scalar types. We will see it shortly, which is like an ID, and that's what you request. If there is an error, so you won't get anything. which is differently with RESTful APIs. Now, regarding the HTTP status codes, so in RESTful APIs, usually we need to deal with, the 200, and then in the body you put some other HTTP status codes, 405, 404, 401, whatever it is. And here mainly we don't care about errors. I mean, we always get 200. And that also makes it a little bit harder for an attacker to realize whether this is an error or not. Of course, if there is an error, so there will be like a short field, JSON field, called error with the message specifying what went wrong. But we don't need to not with any other status codes. So let's just jump about some more terminology about GraphQL. So first of all, we need something called a schema. The schema is what actually defines what we want to query. It's kind of like defining our database, how it's going to look like, what fields we're going to have, what type of queries we're going to have. Okay, because we have something called SDL, which is the schema definition language. It's just defined by, actually it was originally by Facebook, now it's by the GraphQL Foundation, which is, we'll see something similar to, has some similarities to JSON. So the schema is just like, let's say, the big picture, like the database. Now, on top of that, we have something called the object. So the object is, kind of like the type of operation that we want to retrieve. We want to, deliver to the user. And inside each object, we have the field. Now, the field is what specifies the values for an object. So here we have a very, very easy example here. So the schema is of type user. Now we have an ID. The ID is the field of type ID. ID is a built-in type of GraphQL, but also we have the name. And the name is, as usual, a string. And all this makes the object. Now we have another object, which is the type orders. And here is kind of like a table if you want to simulate this to like a SQL database. And you have also a user ID. Now a user ID here in this case is of a type user. Now user is a type that we created. So this is called basically an edge, or it's just a relationship. We can create relationships in GraphQL because at the end, if you remember, what we want to do is we want to query once and get all the necessary information that we want. So in this case, we could get orders, and we could get also the user that ordered that. We could do it even more complex and create a bidirectional relationship between the orders and users, and we can query either to get the rest. Okay, but this just gets more complicated. It's one possibility, but this is just a very simple example of a GraphQL schema. Now, we mentioned about the schema. We have this information that can be queried. So what does that mean? What can we do with that? So there are three main operations in GraphQL. One of them, or probably the first one, is the query. Query is just a read-only. It's just like a GET request. Okay? What we do here is just read-only information about the server, about some endpoint. I want to get all the users that recently signed up to my application. I want to get all the last 10 orders that were ordered in my application. Nothing else. If you try by a query, if you try to write data, if you try to change data, that's not going to work. And it doesn't matter if you are the developer, it's not going to work. Now, another one is the mutation. Now, the mutation is where things start to get a little bit fun, because mutation means that you're going to change data. Okay, this is like if we compare back again to REST. So, the mutation is kind of write, which means create, add, change data, or even delete data. But also at the same time, we can read data from the server. And lastly, we have a third operation, which is the subscription. Now, the subscription is kind of, if you are familiar with WebSockets, so it's basically kind of push notifications with the client. It could be unidirectional from the server to the client, or vice versa, or it could be bidirectional between both. Let's say we're waiting for the user to upload a file. So once we get a file, so then the server gets some sort of notification, and so then the server will send an email. But I'm saying it's commonly with WebSockets, but it could work with different technologies. Now, here, what we do is we first of all define the schema. So the schema says, I want to query. So the query is, in this case, just a user. It means if you want to read the, data based on my schema, so you can do it, as of this example, only to the user's object. Okay. If I try to read, let's say, to the orders by using this example, so nobody will be able to do so, because there is no permission. Actually, there is no indication that a user can actually read the object until we put it inside here. So GraphQL is very cool. Oh, my bad. Okay. So let's just dive a little bit deeper into this. What exactly or how we can do a query. So if we want to get a user's name, okay? So we do this syntax, which I don't know if you are a fan of Python or maybe not. If you like JavaScript, JSON, Java, you will like this as well. So we have a query here, okay, which is like the main operation in this case. And then we have what is called a top level field, which is users. It's kind of the name or of the endpoint, let's say, comparing this to RESTful, and the field that we want to get. Okay, a user could have a name, it could have an age, email, ID, many other information. So in this case, we want to get only the name. So this is on the left side. We get the we write our request. On the right side, we have our response. Okay, so the name here, I hope I pronounce it well, is Alain Berset. Yeah, right? Swiss president. This is not by coincidence. And this is just a very simple query. Okay, from here, you could just put more and more fields. Okay, I mean, there's nothing from the client perspective that avoids or prevents me as a user to put more and more fields. Okay, so we'll see that later. This is maybe an attack surface for GraphQL. Now, what about the mutation? So the mutation, first of all, as you can see here, we need to add that to the schema. We need to say, hey, I want to use, because at the end, we can have, in a complex environment, like, big companies, you might have different schemas, which is very powerful in GraphQL. You might have a schema for development. You might have a schema for different applications. So for this schema, I want to say, hey, yeah, here, I want a mutation. Okay. Let's say if we go back to the weather example. So I don't want any user to change the weather, right? Because they're going to say now in Switzerland, it's really hot. No, here is not, it's not Dubai. So I want the users to only query, to only read the data from my server. So, in this case, because I need to explicitly do that and put the mutation, and it's just very simple, mutation, colon, mutation. And then at the bottom, we can see the mutation itself. So in this case, it looks a little bit daunting. Basically, these are arguments that we put on, just like with any function there. So we have our create user function with the ID. The ID is provided by the front end. In this case, is number 1. So what we want to do here is we want to replace some fields or the name of user. So here we have the password. The password, I just made it up, is Swiss in base 64. You can check it out. And with the name of Victor Rossi. I don't want to kill the president, so don't worry. And what we want to do is just specify the 3 fields: the ID, the password, and the name. Okay, just in case the ID was something completely different. So the response on the right, we just get this, which means that it was updated. Okay, so usually what you request is what you see on the response. Okay, so these are the 2 main operations that we mostly be playing with: the query for read and the mutation for changing, deleting, or adding more data. Now, there's another thing, because GraphQL is a full language here that was created. There is something called directives. Okay, if you come from Python and you know, like decorators, it's something similar here. So what if you want, you have your BigQuery, but by using this kind of directives, you can change actually the whole behavior or how the response is going to look like. Why? Because in some cases you want to ignore data. You want to say, hey, but give me this bit just in case this is not true. So by this example, what we see is we have the list of users and we want to get the ID. We want to get the name as well, but we want to say, hey, if the basics only check mark is true, okay, which can be retrieved from the front end. Let's say the user wants to see how many users are in their database. So just skip the URL. Okay, skip the link from that response because they all want to get just is the ID and the name, nothing more. Okay, so there's a few directives that we can use. Skip, include. There are just a few others. I think there are like 5 or 7 maybe. We can refer to the RFC for that. You will see later on why this is important. Again, because in this case, this is skip, but if you have include, so you might include the password in some queries as well. Also, we have something called fragments. I have no idea why they use this word. I don't know, fragments for me, I don't know, I come from Android, so something completely different. So fragments is the way of reusing the same piece of code, or in this case, the same field for different queries. Let's say you have a query again for retrieving the user, or the username. You don't want to type 30 times user, right? Because there is some principle called DRY or dry, don't repeat yourself. So what we do is we put these 3 dots, which is called a spread operator. We define just some name. In this case, it's called same fields. And we do fragment. We say, okay, what the same fields or the common names that you want to include in every query. So we do ID, username, email. So every query that includes this spread operator same fields, so automatically it's going to include these fields. So in this case, again, this is just very simple. We have just 3 fields, but imagine if you had 12 and you're doing 15 queries. So that will really save us a lot of time. Okay. And we have one more thing here. There's something called introspection. Okay. What is introspection? So by introspection, we can query the server and discover, we can find out about the underlying schema, types, operations, if there's a query, mutation, subscription, directives, everything basically. Okay. It's mainly for debugging purposes. I mean, I wouldn't recommend this in a production environment. But the problem is that it's enabled by default. Okay? Okay? You can use no matter what kind of implementation, and it's going to be enabled by default. The problem is even worse with some implementations, specifically in Java and Go, because you cannot even disable it. What do you do? There are some workarounds there. So just in case you are using Java and Go, make sure you disable this. But what exactly is the introspection? So introspection is defining the query, and we have our magic field here, __ schema. In this case, what we want to get is the whole schema, namely the whole database. And we want to get specifically the names, the name field here. Now, what we get, I mean, this is just an example, but we get a full schema here on the right. We get a query, we get user, which is the name of the field, and we see at the bottom, we see the password field. Okay? So if we manipulate this a little bit more, we'll see later that we can even query and get the password for different users. Of course, if there is the proper configuration in the backend. But this is just their part of GraphQL. So, it's okay. That was probably a lot of information. So, don't stress. This is just art. Because there is something called GraphQL Voyager. This is kind of a UML, or like kind of a graph mode of your whole schema types and everything. It actually draws all the relationships between the different objects as well. This is a little bit complex. That's what it looks like, but it's just to reinforce that if for any reason we have a database, I mean, either we are defending or attacking, so we have a way of visualize that in a much more convenient way. Okay. And it's not just, kind of, having all text. It could be much easier. Of course, we'll need to manually look at all this and find the relationships between the dangerous objects. And this is free, actually. You can just download it from GitHub. A few endpoints, a few ways where we can find GraphQL is, of course, on the slash, on the root path, just because. But there are a few more. We can see this, of course, on the slash GraphQL. There's a slightly different version, GraphQL. We have the V1, version 1, version 2, version 3, slash GraphQL. We have slash API, GraphQL, slash API, GraphQL, slash console. Okay. I have no idea why they made it up this way, but it works. Slash playground. Yeah, that sounds very cool. Slash GQL, slash query, and it's not really, for only queries. Okay. This is the GraphQL endpoint, or simply index.php and question mark GraphQL. This means that, again, if we are trying to defend ourselves, just make sure that only the right people or from the right sources, they have access to your endpoint. Okay. And for any reason you don't have any app, debugging app, IDE or something else running in the background. So now we saw everything about GraphQL. We need to compare now, GraphQL and see more advantages versus, the REST API. So, as we mentioned earlier, we have the ability of just query one single endpoint in GraphQL. Just name any slash GraphQL. And by REST APIs, you probably have many of them. Okay. If we just Google quickly for the weather forecast app, AccuWeather, YouTube, you probably have dozens, if not hundreds of them. And each one with different specifications. So this makes it a little bit harder because, first of all, maintaining all of this, you forget this is internal, this is not, who has access to this one, how many fields, if you're required to have authorization, if it's just SSO, if not. So this makes things a little bit more complicated. And if we talk about, let's say, GraphQL, so it's just much simpler. For sure we can have more than one endpoint, but usually it's enough with one. Second of all, as we mentioned earlier, with GraphQL we use only post methods. There is a way actually to use get methods, but it's not recommended because that could lead to some CSRF attacks. But technically you can, but you are, using usually post methods. But by using REST, again, you need to deal with delete, put, patch, head, get, options. There are just too many HTTP methods there. Another advantage here of GraphQL is it's called over or under fetching, which means either you get more information that you requested or you get less information, but you don't get the exact information in RESTful APIs. So by GraphQL, you get exactly what you need. You ask for the user, you get the user. You ask for the name only, so you get only the name. You don't get the full description or the user with all the details as well. And the front end, it's an acronym here. So the front end must match exactly of the changes that you do with the back end. And in GraphQL, probably you have your PM, you have your customers. They want to do some changes specifically to the API. They don't want to be called orders. They want to be called all. So what do you do now? You need to change everything in the front end. You need to change everything in the back end as well. it's just time consuming. In GraphQL, it's just going to be the same endpoint, GraphQL, and only you change specifically in the backend or maybe just in the front end about what your customer, your PM wanted to change. If it's just a few fields, okay, just remove them, add them, and just play around with that. But it's much more cost effective also by using GraphQL. Another advantage here is that we mentioned that it's strongly typed. You cannot mess around with different types. If the user put number 1 as a string where it should be an integer, or if the user, because that could also lead to some attacks. If on the phone number the user put the email, not because they made a mistake, but because they wanted to enumerate or try to attack your server. So that could be directly rejected by the server by GraphQL because you asked specifically for a type. And in REST, yeah, you could do that. You could still, of course, in the backend, compare, PHP, Java, whatever, JavaScript. You could use the 3 equal signs to compare both the type and the value. But, you would need to do that for every single value. And here, it's just made by, the schema. It says you get only that type and that's all. Besides that, in GraphQL, you also have the ability to create your own type. Okay? You create your user type like we did before. You create kind of like your class with all your, fields, with all your different values that you request. So it's much more granular than just REST API. But there's one thing, at least here, that REST APIs are still good. I mean, we need to still consider if we really do some complex and very, very nested queries, nested APIs with GraphQL. It's a little bit different here. Because with, imagine like you nest more, that could lead to denial of service or simply crash the GraphQL endpoint if you don't do it properly. Or even if you do it and some attacker plays around with your API. And in, the traditional RESTful API, that will be just easier. And also, by caching responses, so a RESTful API, it will be better because, the API will always return the same response. But in GraphQL, it's enough that you change just one field on the same endpoint, the same operation, and you're going to get a completely different response. So it's still possible, but it's just a little bit more complicated to cache your responses. So it means that if the response, let's say, lasts 10 users, that a couple of users are trying to query to your server. So it's going to take a little bit more because the server will need to again process that and retrieve back to the user. So only for this reason, I would recommend to, at the end you could work with both. You could combine GraphQL and APIs. So specifically for that, for those complex queries, so you can use better RESTful APIs. So this is a very interesting example here, just to illustrate what GraphQL can do here. So at the top, you can see the RESTful API. You have your api.com/burger. You get everything. Okay? You get the bun, you get the bread, you get the patty, you get everything you get. There's no way to specify, I want just this and that, field, or in this case, pieces. Of course, you can filter in the backend, you could apply some limits, but it's harder. It's not by design. And here in GraphQL, just specify what you want. You said bun, patty, bun, and lettuce at the bottom. So this is what you get. Okay. As you can see, there's no cheese here. Okay. And this is, GraphQL versus, REST API. Now, let's see some usage, statistics. Who uses that? Why they do that? So GraphQL is everywhere. Okay. Sometimes we don't realize about that, but it's actually there. So this graph was taken from Wondergraph. It just illustrates the popularity of GraphQL. This is the amount. This is until actually 2 years ago, but it reflects here the amount of, there's most, 4 million of repositories, 4 millions that were created just with a word or with some tool regarding, GraphQL. Okay. And again, this is just GitHub. We could even have more data about GitLab, Bitbucket, and other, technologies, other platforms. But as you can see also, there are big companies, just like Facebook, GitHub, Pinterest, Coursera, Shopify, and there are just many companies that adopted already this technology, and they're even contributing to the advance of this great technology here. And again, this is just an example taken from GraphQL.org. There are just millions, probably other websites that are using this technology as well. And the reason, because it's just much more flexible, as we talked earlier. Now, let's go to the fun part. Let's see a real exploit scenario of how we can take advantage of GraphQL. I mean, it's great, but everything comes with their part on the side. So, not a long time ago, there was an attack in Shopify. Shopify, I guess you are familiar with. It's a website, it's an e-commerce that you can mount, you can use and sell your stuff. You can kind of, use their service for that. And what's more fun about this is that Shopify, they actually, as we mentioned, they contribute and they develop tools for GraphQL. So they had a vulnerability, in their website. And the way of exploiting it was to first enumerate, to first discover what's going on, analyzing the endpoints, analyzing the fields that can be sent to the to Shopify. Of course, it's it sounds maybe easy, but it takes a lot of effort here. And once that the endpoint that was actually lacking authorization, it was found, then the email, basically what happened is that you could send a mutation to an endpoint and there was no authorization. It means you could update any email just by changing your email. Okay? You just found the endpoint changing your customer's email. So then you just change that. You simply change the endpoint or the host where your victim is, and you could change every single customer's email as well. So after manipulating the mutation, we can just simply send that, with any proxy, Zap, Burp, whatever, Fiddler, just manually with the CURL. And that was enough just to, exploit that. So let's see this in a more technical way. We have here the mutation that was in Shopify. So email sender configuration update, nothing really that tells us a lot. But here we can see that the ID that was sent is basically the email. Okay. We could figure it out that there is no really, authorization, at least from this, on this side. We don't send any token. We don't send any, API key or any password here, to the endpoint. So that could be one way of identifying that there is a vulnerability here. Then we could just play around with the different fields. We could add more fields. We could just, delete or add some arguments there. And this is just a screenshot of, how it looks like this is in Postman. And lastly, this is how we can change the customer's email here. Again, now this is just one example. There could be many other examples that we can see shortly. So, there are many vectors, many ways of attacking, or many ways that we can defend ourselves from attackers here. So one of them is injections, just like with any other technology. So there was also an attack in Nuri. I think Nuri, there was a blockchain bank or something, a financial institution, and they had an injection through WebSockets there that affected their service. But also there was an SQL injection. Why not? SQL injection just by, putting the apostrophe and doing the query. You could just do whatever you want, job the table, add users, manipulate the database. And that was in HackerOne. HackerOne just, it's a platform used by hackers. So hack the hacker. There was also a denial of service. Denial of service, by, recursively putting more and more fields. You could just nest more and more, levels, 8, 10, 13 levels of, objects there and putting more and more fields. We could just do the same with fragments, just putting the ... and naming the same function 30 times with different names. Okay. So basically we are kind of doing 30 different operations, but at the end it's just the same with different names. And the same thing with, directive. So that happened in Magento that I mentioned before, which is the directive is the, at, skip, include, or some, a component that changes the behavior of the response. So if it's a skip and you do include, so you can include some other information that wasn't unintended. There was, scrt also is another attack vector. I didn't hear about any attack in that, attack surface, but it doesn't mean it didn't happen. If you don't hear, it means it didn't reach out to the news yet. We have also CSRF or CSWSH, which is the same thing as cross WebSocket hijacking, and it just basically happens if you use GraphQL over get method, because there's no authentication there. So we should be careful about that as well. Authorization authentication bypass. Okay, this is also another issue in Git, in GraphQL. It happened in GitLab. It happened in Shopify again. Also privilege escalation, simply by changing the ID, changing the role from regular user to admin. Also, hacker one was vulnerable. Other attack vectors include less or low vulnerabilities, which is enumerating the field suggestions. Usually, GraphQL tells you something like, if you were wrong in writing a field, like just Google, they suggest you another field similar, with a similar name, and they tell you, the response says, did you, refer to maybe this title? Did you refer to that? So basically you are enumerating the schema. You're enumerating the GraphQL endpoint. And lastly, when we are mishandling errors. As usual, when we send errors, we don't need to send the whole stack trace or the whole database error. We need to just send exactly what we need. So these are the attack vectors. Now, how we can remediate those? How we can defend ourselves from these attacks by using a great technology? So first of all, disable introspection. Of course, if you're using Java and Go, so you need to find a workaround. But don't expose this, at least not in a production environment. Don't expose your schema. Don't let users query your schema or types or any other any other piece of information about your GraphQL endpoint. Also, some developers, they like to preload some queries in JavaScript libraries. They do it because of performance, so try not to do that, because that gives a hint to attackers. Also, use only post requests. And again, because by using GET requests, you could be automatically vulnerable to CSRF. Next, set the query depth limits and timeouts. To avoid denial of service, you have like a way of limiting the fields and limiting the time of how every query should last. If the query lasts for more than 3-4 seconds, that's too much. Just reject that. Also calculate the field's height. If you have only 8 fields, that's all you're gonna get. If an attacker puts 11, so that's enough to reject the request. Return generic errors. Just, kind of something went wrong. Instead of you have an error in your SQL syntax in line 92. And lastly, as a general rule, is sanitize and validate all the fields. Every single field needs to be validated, because if you request again a phone number, don't expect the user to send only numbers. Okay? Even that you have your front end, JavaScript is, actually even HTML is only letting users to put, only numbers. don't expect that, because that could be easily changed by proxies, by many other tools. And if you expect that and a user sends something else, you could be in trouble. But not only that, every single piece of data that you ask for the user, every input, every search, every field that has a text box, or even any piece of data that, input hidden, that the user can send back to the server. So that needs to be validated and sanitized. Sanitized means, to simply remove the special characters, those characters that you're not expecting, like an apostrophe, maybe expected if you are in America, for, McDonald's for a name, but that's not expected for an email. Okay. Because that's not valid, or Unicode, letters or characters in emails, that's not also expected. So for that specific, try to sanitize. And there are just many best practices around the internet for that as well. Okay, so that was all. You are awesome. And thank you so much. Hope you enjoyed.
Okay, you know the drill. Any questions? My site is based on movement, so if you don't move, I don't see it. Yes.
You talked about hiding field names by not having suggestions. Shouldn't it make more sense to have an authorization on which fields can be carried by which user?
Yeah, you're right. I mean, you should, every operation, let's say the type user, it should be always checked against authorization and authentication. That's first of all. I mean, you have a schema. You have a schema that only specifies, say, the ID, name, username, age, and that will be only stick to, let's say, the user that the ID matches to, let's say, the cookie. That will be really the idea. Of course, you could have another schema for admins that they can query, let's say, support, technical support. They can actually query and even mutate the password with the right permissions as well. Yeah, you're right.
Thanks so much for the talk. Very interesting. When you do an enumeration of the service, GraphQL, do you have access to the schema, or you need to use some brute force technique?
By default, yeah. By default, the introspection is enabled. Yes. But even if you don't do that, I mean, there are other ways of enumerating. You could simply, just, throw your own field name. And if you don't get an error, so it means that the field exists. So it doesn't, I mean, yeah, it's not implied that the introspection is disabled. You could still have some other ways, but that's still enough to, again, you could have rate limiting, you could have a WAF, which also help mitigate those attacks as well. Yeah, great.
Final question. Okay, so suppose I have an app that I want to pentest that uses GraphQL, are there any tools that are available to fuzz the APIs that use GraphQL or anything?
You mean tools to defend?
No, to attack.
Tools to attack. There are a lot. You could use simply, if you know Burp Suite.
Yeah.
So there is an extension called InQL, I think. So it's just available in the provisional version. You have a GraphWoof. I think I show it. GraphWoof to enumerate the endpoints just automatically. You have WFuzz. You could use also SecList for check, discover, different fields, endpoints. Are just huge, word list there. Besides that, I think that would be enough. That would just.
Thanks.
Yeah.
Okay. Thank you, Leo.
Thank you so much.